Warm up. We got 32 over 1 plus 24 e to the negative 0.5 t. Solve for t. Solve for t. Whoa. Solve for t. I didn't say for t, but that's the variable there. What type of function do we have on the left? You remember? That's a logistic function. Yeah, it sure is. All right. And we're trying to solve. So the first thing we would do is multiply both sides by the denominator, and then we can divide both sides by 64. So if you want to do that, you can, but then you're going to have a fraction. So let's just do it in two steps. 32 equals 64 times 1 plus 24 e to the negative 0.5t. Now, if you divide by 64, we're going to have 32 64ths, which will be a half. Do you want a fraction? Let's just do this. Let's just divide it out this way. 32 goes into itself once. 32 goes into 64 twice. So we could simplify it like that without having a fraction. Or you could divide through by 64, simplify 32 64ths to a half, and then remultiply by 2. But I would do something like what we did yesterday with the double zeros. All right, now to avoid a fraction, I'm going to go ahead and distribute the 2. So I get 1 equals 2 plus 48 e to the negative 0.5t. And now we got to isolate the variable terms. So we'll subtract 2. So we get negative 1 equals 48 e to the negative 0.5t. And then I'll divide through by the 48, and I get negative 148 equals e to the negative 0.5t. And now I'll do what? How do I un-e it? Natural log it. Now, is this going to even work?
No.
No. Let's go ahead and finish it just for the sake of the algebra here. But I got a log of a negative number. So now this is the same as negative 1/2. Let me go ahead and write negative 0.5 as negative 1/2. It just makes it a little bit easier to solve. Now, I was talking to my niece yesterday. She called me. We met on Zoom last night. She's in 6th grade, and they were solving linear inequalities. And her last problem was the hardest one, and it had a negative 1/2 t. And I told her you have to multiply both sides by the what? Reciprocal. And she said, I've never heard that word before. Her teacher had never taught them the word reciprocal when talking about multiplying by the flipped fraction. She goes to Lavernia. Can you imagine? Can you imagine having to multiply by the reciprocal without even being told it was the reciprocal? That we got to go fix. We have to fix education, folks, right? But guess what she forgot to do on the inequality when we multiplied both sides by a negative 2? She forgot to flip the inequality, and that's why she was doing test corrections. And I'm like, oh my gosh, you are making me look bad, niece. She goes, my teacher doesn't even know you. And I said, yet, because I'm going to call her this afternoon about that reciprocal thing.
Are you actually?
No, I told her to tell her teacher, and she goes, if I remember. Yeah, so which means she's not. So there's no solution. I was like, what does your teacher tell you to do? She goes, I don't know. Great.
So, Mr. Cookie,
Yes.
if you give us this question on the test, could we stop when
You can stop as soon as you get a negative natural log. Yeah. Yes, yeah, absolutely. Or a log of a negative number. I just went through, I made it up on the fly this morning, and I happened to make up something that didn't have a solution. Yeah. And you could probably tell because what's the limit to growth? 32. And what am I trying to set it equal to? And 64 is a little bit bigger than 32, isn't it? So you could actually say, you could actually say no solution in the very beginning if you recognize that 64 exceeds the limit to growth. But it serves its purpose. All right. Real quickly here, when I go to second period, I'm going to change 64 to a 16. There we go. So they'll get to do it without no solution. All right. We did example 5 yesterday 2 different ways. We did it up here, either exponentiating both sides or just doing the around the world thing. Either way, we converted the log to the exponential, which is typically what we're going to do. The log converts to an exponential, which allows you to free up the argument, and then you can solve. Okay. Now, there's one thing we have to concern ourselves with logs. Remember, unlike exponentials normally, they have a domain. The log equations have a domain. We can only take logs, as we saw in the warm-up, of what types of numbers? positive number. So you have two options here. You can either find the domain of the log equation before you start, which we did up here. X has to be greater than -2, and then you compare your answer to that domain. 79 is bigger than -2, so it works. Or you try out your answer on the back end. You plug in a 79 for X, and you get 79 plus 2 is 81. 81 is certainly a positive number, so it'll work. Okay. I might ask you for the domain of the equation, and sometimes there's two of them, so we have to consolidate them. All right, let's look at example 6. Solve log base 10, it's implied base 10, remember, of x squared equals 2, two different ways, using the properties of logs to simplify and then converting it directly to exponential. So we'll call this part A with a stupid highlighter. We get log of x squared equals 2. Now, that 2 that's up there, I can bring it out front and say it's 2 log base 10 of x. Yes, yes? Yeah, and now I can divide both sides by 2, and then I get 2 divided by 2 is 1. Now, how do I get at the x? How do I unlog something base 10? You exponentiate both sides base 10, or you do the around the world thing, right, which is where I like to write the 10. I don't care which one you use. The around the world is almost a little bit easier. You don't have to write as much. So you get 10 to the first equals x, so that means x equals 10. Now, we got to check it since I didn't find the domain in the beginning. You plug it in. Back to the beginning. What is 10 squared? 100. Is that a positive number? Yeah, so it works. All right, that's part A. Now, part B says to just convert it directly. Oh, so it was log of x squared equaling 2, and notice that we already have the log isolated. When I brought the 2 down, I isolated the log. The log is currently isolated, so let's see what happens when we convert it right away. 10 squared equals x squared, so x squared equals 100. And now when I take the square root, I get x equals what? 10. Or, don't be like my niece and forget to flip the inequality. Don't be like my niece and forget to do something. Plus or minus. When you take the square root, you got to do plus or minus, yeah? Yeah. So we already know that the positive 10 is going to work. Let's see if the negative 10 works. If I plug negative 10 right up here for x, what's negative 10 squared? Positive 100. Is that a positive number? Yeah, so do they both work? Yeah, so which method was actually correct? B. Why was A incorrect? I didn't get the negative solution. I have impartial solutions. Okay, so here's the moral of the story. You want to isolate your log. You want to get it to log base B of some function of x right here equals, we'll just call it A. If you can isolate the log, that means its leading coefficient is 1. You've isolated the log. Then you can just go b to the a equals f of x. What happens is you take a quadratic equation in the argument, and by bringing the 2 out front, you turn it into a linear equation, right? A quadratic equation like x squared can have 2 solutions, 2 x-intercepts. By bringing the 2 out front, you turn the argument into linear solution, which can have only how many solutions? 1. Okay? So you kind of destroy the original problem by bringing the 2 down. All right? So if your log is already isolated, convert it directly to exponential by exponentiating it, whatever the base is, or doing the round the world. Okay? Don't overcomplicate it. That's the moral of this story. All right. Let's try it out here. We're going to have some multiple log terms in these problems. Solve the following log equations. Okay. Our goal is to isolate the log. So I want to get this by itself. Think of this in algebra 1 as just being x. If this were 4 plus 3x equals 16, how would you solve for x? What would you do first? You would subtract 4. Okay. So we're going to get 3 log base 3 of 2x equals 16 minus 4 is 12. Now, how would you isolate the log? How do you get rid of the 3? Divide by 3. So I get log base 3 of 2x equals 12 divided by 3 is 4. Good. All right. Now that I isolate the log? Yeah, I did. I isolated the log, single log. So now I can either exponentiate both sides base 3, which if you do that, you're going to have to show this right here. What would 3 to the log base 3 of 2x be? 2x, and then 3 to the fourth. Can we simplify that?
Oh, I guess 81.
Yeah, 81. It's 9 squared. And then I solve for x, and I get 81 halves. Now, let's check. We didn't find the domain. You plug it back in right here. What's 81 halves times 2? 81. Is 81 a positive number? Yes, so it works. You might get extraneous solutions sometimes. Okay, so the last thing that you do is you check your answer. Check your answer. All right, look at letter B. I want to isolate the log. Do I have the log isolated already on the left?
Yes.
Notice I said isolate the log. Is log plural?
Yeah. No.
No, it's singular. How many logs do I have on the left? 2. Is it isolated? No. No, there's 2 of them. He has company. He's not by himself. So what do I need to do to turn 2 log base 10s into 1 log base 10 if they're added together? What was the property? What was the property? Did we expand or condense? Condense, right? We need to condense. That was the term. Now, they both have coefficients of 1, so we don't have to bring any coefficient up as an exponent. We just pull 1 log base 10 out front, and I'm going to put brackets, and you already mentioned it. What do we do with the arguments since they're added? We multiply them, x plus 2, x minus 1. And that equals 1. Now have I isolated the log? Yes, so now I can convert it to exponential, or I can exponentiate both sides base 10. What's 10 to the log base 10 of blob? Blob. And that equals 10 to the first, which is 10. Okay, now I'm back in algebra 2. Can I set each of these factors equal to 10? X plus 2 equals 10 or x minus 1 equals 10? X plus 2 equals 10 or x minus 1 equals 10. Does that work? Oh my gosh. You're going to get thrown into a volcano if you do that. It only works like that if it's equal to what, Brady? 0. And although 10 has a 0 in it, it is not equal to 0. You can have 2 numbers multiplied together equaling 10, and neither one of them is 10. Okay? It only works with 0 that one of them has to be 0. So, what do I have to do instead? Subtract the 10. So I get x plus 2 times x minus 1 minus 10. And then what? It equals 0. But now it's no longer factored. I got 2 terms. Foil it. We got to expand it out and combine like terms. Yeah. So this becomes x squared. I'm going to do the inner and outer together. The inner is 2x. The outer is minus 1x. 2 minus 1 is plus x. And then we get the last is minus 2 and then minus 10. So first outer, inner, last. Now I can combine the negative 2 and the negative 10, and I get x squared plus x minus 12 equals 0. Not 10, 0. All right, now I have a quadratic trinomial. I look to see if I can factor it. And this is an easy one if it does go. If not, we have the quadratic formula, which y'all know, but it is written on the backboard for the Algebra 2 kids. Okay, let's hope we don't have to use it. Let's hope it factors, right? Factors of negative 12 that add up to positive 1. 3 and 4. Yes, we got x and 3, x and 4. And which one has to be positive if the sum is positive?
4.
The 4. Yeah, there we go. Now can we set each of these factors equal to 0? Yes, so x minus 3 equals 0, or x plus 4 equals 0, which means x equals 3, or x equals negative 4. Now remember, I encouraged you to skip this line right here. I want you to be able to look at x minus 3, the factor, and know that x equals 3 is the root. I want you to be able to look at x plus 4, the factor, and know that negative 4 is the root. Now, I never found my domain in the beginning, so what do I need to do with both of these? Check it before we wreck it. I got to plug it into both log arguments. Bless you. 3 plus 2 is what kind of 5? Positive 5, that works. 3 minus 1 is positive 2. So 3, welcome to the club, 3. Now we plug in a negative 4 into both of them. What's negative 4 plus 2? Ay, caramba. What type of 2? Is that allowed? No, this was an extraneous solution, so we'll just draw an X through it. I want to see that you found it, and then I want to see that you threw it into the volcano. Draw an X through it. Yeah. Now, why did that happen? Let's take a look. This is a linear argument, and this is a linear argument. They're both of the form mx plus b. Linear arguments can have how many solutions did we already say over here? They just have one solution, right? But when I condensed it, what did I do? I created a quadratic which can have two solutions. One of which could be what?
Wrong.
Yeah, what's the proper term? Wrong. Yeah. Wrong is another word for extraneous, I guess. What would be another word for reciprocal? I was asking her, what did your teacher call that if she didn't say multiply both sides by the reciprocal? I don't know is the only response I got. She's a sixth grader. Flip, right? She didn't even say that the teacher said to multiply both sides by the flip. That doesn't even sound right. Multiply both sides by the flip. We're in Lavernia. Multiply both sides by the flip. The flippity dippity doo doo. I don't know. She didn't know the word reciprocal. All right. Y'all do this one by yourself. You're going to have to condense, but notice this one has coefficients of 2 and 3. So what's the first thing you're going to have to do? Bring the 2 and the 3 up if you want. Okay. I'm going to give you a couple of minutes to do this one on your own. Go. Use what we just did as a template or a template. Let's see. I'll set myself how about 3 minutes? If you're watching the video, I'm not pausing it. Just try it on your own and let the video run. Done. That's 3 minutes. All right, let's see how you did it. There's actually two ways to do this. So let's go ahead and let's kind of draw like a little fork. We'll do it down the left-hand side here. The way that I kind of encouraged you, and maybe you followed my advice, is to bring the 2 up and to bring the 3 up. Now, realize what we do there. Just like over here, when it started as a quadratic and we made it linear, we lost a solution. Here we're taking 2 linear arguments, x minus 5, and we're making them quadratic and cubic. Now we're inviting extra solutions. Does that make sense? We either get rid of a solution if we lower the degree, or we invite extraneous solutions when we raise the degree. That's okay as long as we remember to check our solutions at the end, we can catch them. All right, now I can condense. This is log base 4 of the positive terms argument goes in the top, the negative terms argument goes in the bottom, and that equals 1. Now, look to simplify. Those are the same factor, aren't they? So does that simplify? To 1 over x minus 5, doesn't it? There's 3 factors in the bottom, there's 2 factors in the top. So 2 of the factors will simplify. Okay? Now I've isolated the log and I've simplified the argument even better. Now I can convert it to exponential. So you either do the around the world or you exponentiate both sides base 4, which is what I'll do. So we end up with 1 over x minus 5 equals 4 to the first, which is 4. All right, now we're back in algebra class. How would we solve? Multiply, so you get 1 equals 4 times x minus 5. And here you have the fork in the road again. You can either divide by 4 and work with fractions, or you can distribute the 4 and let the fractions appear on the last line. I think we're just going to let the fractions appear on the last line. So I'll expand it out. 4x minus 20. I add it across, and I get 21 equals 4x. So x equals 21 fourths. I only got one solution. Is it guaranteed to work? And it's not guaranteed to work. We better plug it back in right here. What's 21 fourths minus 5? It's a positive number, right? Because 21 fourths is the same as 5.25. Or you could say 5 is the same as 20 fourths. That might be easier. 5 is the same as 20 fourths. So 21 fourths minus 20 fourths is 1/4. Woo, it snuck into positive land, didn't it? Not by much, but does it work? Yeah, it works. All right, now, here's the other way to do it. You don't get this that often, but when you do, you might want to take advantage of it. We actually have like terms right there. Notice that? We have 2 of those minus 3 of those. Bless you. 2 of those minus 3 of those, where those are log base 4s of x minus 5s. So what would 2 of them minus 3 of them leave us? Not just one of them, but negative 1 of them. So I get negative log base 4 of x minus 5, and that equals 1. Now here you can multiply both sides by negative 1. So you get log base 4 of x minus 5 equals negative 1. And now we convert it, or we log both sides, exponentiate both sides, and you get x minus 5 equals 4 to the negative first, which is x minus 5 equals 1/4. And now we add 5 to both sides, and we get 5 plus a fourths, which is the same as 21 fourths. They're both correct. Both methods are correct. It's just a matter of which one you see, right? If you see that you want to condense it first, do that. If you want to see that they're like terms, do that. I think they're probably both just as easy. The one on the left, you don't work with fractions until the very last line. This one, you actually have the 1/4 to contend with for a little bit. More than one way to skin a cat, right? What's the goal? Skinless cats. Skinless cats. Get that skin off however you can. Just get that skin off. I don't see any skin on that cat. Dozens of times, but never the same way twice. Yeah. All right. You got the hang of it? All right. Look at part D. I got log plus log. I think I condensed that, but I got a log on the other side now. Do I need to bring the log from the right-hand side over to the left-hand side? Not yet, no. In fact, I don't really think I need to because remember this GTBTS from above? It said not just with exponentials, but if you have log base b of x equaling log base b of y, then what? X equals y. Yeah. So I wouldn't need to do that. But let's go ahead and condense the left side. The coefficients are both 1, so I can pull out a natural log. And what do I do with the two arguments if the terms are both positive? Multiply. So I get 3x minus 2 times x minus 1. Now, be on the alert here. I have two linear arguments to start with. They're both mx plus b with one solution. And now I'm multiplying them, which is raising the degree to a quadratic. There's possibilities now of extraneous solutions appearing. What would I do on the right-hand side? What would you do with the 2? I would bring it up, yeah. So we get the natural log of x squared. Now, again, I'm raising the degree. I'm elevating the degree. Extraneous solutions might sneak in. Do I have the bases the same on both sides now?
Yeah.
Yes. So you can either do this. You can either e both sides, right? You can either e both sides, or you could just say so, which would be by the theorem. And let's go ahead and multiply this out here. We'll get 3x squared minus 3x minus 2x plus 2, and that'll equal x squared. We equate the arguments. Now we get everything on one side and combine like terms. 3x squared minus x squared is 2x squared. And then we get minus 5x plus 2 equals 0. We have ourselves a quadratic trinomial again, don't we? We have the quadratic formula. We know what it is. It's still written on the backboard for the Algebra 2 students. Don't you dare sneak a peek at it. You already lost the game, Peyton. You have to have it memorized. You're not an Algebra 2 anymore. Or it could factor. It could possibly factor. It's one of the fun factoring ones, right, where the leading coefficient isn't a 1. So let's try factoring first, right? When in doubt, just say, F it, right? Now, the 2 in the front is prime, so it's got to be a 2x and a 1x, and the 2 in the back is also prime. So it's either going to be a 2-1 combo or a 1-2 combo. I need to get a negative 5. So I think it's got to be the 1-2 combo. It's got to be the 1-2 combo, so I could generate a factor of 4. What am I doing? I'm trying to erase. Okay. So it's got to be the 1-2 combo. That gives me a 4 on the outside, a negative 4 on the outside, and a negative 1 on the inside. And that gives me a negative 5 sum. And then the last two, the product, is positive 2. That works, doesn't it? Okay. Now, let's see if we could skip the step of physically setting them each equal to 0. And let's see if we're not honors pre-cal students, we can't just rattle out the roots. If 2x minus 1 is the factor, what's the root? 1/2. Good. 1/2. In your mind, if you need to, set it equal to 0 in your mind, bring the 1 across and divide by 2. It becomes positive 1. You divide by 2, it becomes positive 1/2. The next one is a little bit easier, right? Because it's just x minus 2. What's the root? 2. Do we box them up like that and move on? They both work. We got to check ourselves, yeah. Let's try the 1/2 first. We'll plug it into both places. You got to get a positive argument in both places. When you plug in a 1/2 to the first one, 3 times a half is 3 halves. What's 3 halves minus 2? It's negative, isn't it? 3 halves is really 1.5. And 1.5 minus 2 gives us a negative answer. So I'm drawing an X through it. I'm not going to obliterate it. I still want to be able to see what's underneath there. Let's try the 2 now. Plug in the 2 to the first one. You get 6 minus 2, which is positive 4. Plug a 2 into the second one. 2 minus 1 is positive 1. So it works. So you don't have to box it. If you don't throw an X through it, I know that it's the one that you want to keep. Okay. There you go. Fineasy. 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 Easy. Easy. All right. Go ahead and try part E on your own, and I'll give you another 3-minute timer. If you're watching the video, keep the video going and try it for yourself. 2 days in a row?
It was almost 2 days in a row that I got it.
Oh. Oh, you're doing Wordle again.
Yeah, I already did it.
To heck with math.
I already did it.
Yeah.
Yesterday was like so.
Is it always 5 letters?
Yeah,
Yeah.
you can do different ones that are like harder though.
Oh, with more letters?
Yeah, there's like different websites that have like a 10-letter word. It's really hard.
Like Satan's portal would have like a 15-letter word.
I guess like girls gone wild.
Yes, right, right, right. Wordle gone wacky.
Wordle gone wild.
Wordle gone wild, yeah. All right, that's 3 minutes. Let's see how you did. Um, you got 3 logs here. You got 2 on the left, 1 on the right. If you can condense them, you can. They're all base 2. That's good. You can equate them. So I'm going to condense the left side. There's nothing to bring up. They're both 1s in front, so it becomes x times 3x squared. And then on the right-hand side, it's already log base 2 of 24. Now I can either equate the arguments by saying so. That would be doing it by the theorem. Or algebraically, I can show that I'm exponentiating both sides base 2. Either way, you either write the 2's or you put the word so. I kind of like putting the 2's there. So I get 3x cubed equals 24. I got to solve for x cubed, so I divide through by 3, and I get 8. And I take the cube root, and I get 2. And then I check, right? If I plug a 2 in here, and I plug a 2 in here, I get positive numbers. So guess what? 2 is the answer. Yeah, that makes a good quiz question right there. That's really straightforward, isn't it? There's not even an extraneous solution to throw out. It's almost too easy. I see why you were doing Wordle. Something more worthy of your time. All right. Holy moly, smokers. What do you notice about these 2 logs?
They're not the same base.
They're not the same base. Uh-oh. We can't condense them if the bases are different. So we have 3 options, really. We can make both of them base 100. Ugh. We can put them both in terms of some third-party base. Ugh. Or we can write them both in base 10. Yeah. Yeah, I would choose to put them both in terms of base 10, which is the common base, right? Because 100 is the power of 10. Yeah, yeah. Yeah, yeah. So let's go up to the side so we don't have to keep writing everything down. I just want to focus on not a highlighter, stupid highlighter. I just want to focus on log base 100 of x squared. So here I am on my workbench. Let's use the change of base formula and write it in terms of base 10. So that's log of x squared over log of 100. Okay, that looks good. So that's log of x squared over, what's log base 10 of 100? Yeah, that's log, if you want to write the base, that's base 10 of 10 squared, right? So what's log base 10 of 10 squared? It's just 2. Orale! So that's going to become 1/2 log of x squared. Now, because I have to condense it, what do I have to do with the 1/2? I got to bring it up, don't I? So that becomes log of x squared to the 1/2 power. And what do I do when I raise a power to a power? I multiply. And what's 2 times a half? Oh my Jiminy crickets. That's just equal to log base 10 of x. Do you see why I did that off to the side? If I were to do that in the flow of the problem, for every single line you see, I would have to have minus log of x cubed equals 6, minus log of x cubed equals 6, minus log of x cubed equals 6, minus log of x cubed equals 6. Wordle, right? I'm going to lose track of what I'm doing to switch to Wordle. But because I did it off to the side, I got the log base 10 of x, and I could just bring that in on the very next line.
Good morning, Unicorns. Teacher, pardon the interruption. Just a reminder that we are starting the send-off for our cheer team headed to the national competition. We are starting at this time. Thank you.
Where do they go?
Chicago, maybe? It's in Dallas. Oh, it's in Dallas. All right, so I condense it now. I pull the log out. The positive term x is in the numerator. The negative term x cubed is in the denominator. And now I can simplify that. That's log base 10 of what's x over x cubed? 1 over x squared. Good, and that equals 6. All right, now I can convert it. I exponentiate both sides base 10, or I use the around the world thing, either one, and I get 1 over x squared equals 10 to the 6. Ay, caramba. Yeah, how am I going to solve for x now if it's in the denominator? I can multiply both sides by x squared, so I get 1 equals, I'm going to leave it as 10 to the 6, because as you mentioned, that's a big number. I think it's like close to a gazillion. At least a million, right? And now I can solve for x squared by dividing through, so I get x squared equals 1 over 10 to the 6, and then I take the square root of it. Now, taking the square root of something is the same as raising both sides to the what power? 1/2 power. So that's what I'm going to do. I'm going to raise both sides to the 1/2 power. So I get x equals 1 over, what's the new exponent on the 10 in the bottom when I exponentiate? I get 10 cubed. Oh, that makes it a little bit better. So x is 1 over now, 1 over 1,000. 1 over 1,000. And that's guaranteed to work, isn't it? No! It's not guaranteed to work. You can have a log equation with no solution. You can have one log opening up to the right and the other log opening up to the left, and they don't intersect. We got to check it out. Y'all have already forgotten the word reciprocal. Let's try plugging it in. 1 over 1,000 squared, is that a positive number? It's very small, but it's still positive, yeah? 1 over 1,000 cubed, is that still a positive number? That's a much smaller number, but it's still positive, right? So now, since it worked in both of the logs, does it work?
Yes.
Yes. Now we can leave it. You can box it if you want, or you can just leave it as the bottom line, but you're done.
So if you do the power of 1/2, you don't have to take account plus or minus.
No.
If you squared it, it'd be plus.
Oh, yeah. Oh, that's right. You're right. Or, hey, way to catch it, Brady. I am taking the square root, aren't I? I was getting on y'all earlier for forgetting plus or minus, and here I am. I forgot the plus or minus. And you know why I forgot the plus or minus? Because I didn't write it as the square root. My brain over the years is triggered when I write the square root to do plus or minus. My brain is not triggered to do plus or minus when I raise it to the 1/2 power. But Brady's is. Let's check that solution. Does negative 1 over 1,000 work? When I plug it in here, what's negative 1/1000 squared? Is it positive? It is positive. So that one works. What is negative 1/1000 cubed? Negative. Wah, 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 wah. So if this were a multiple choice question, would I have been serendipitously lucky to get the right answer? Yes, I did not consider the negative, but the negative ended up not working. So on a multiple choice, I would have gotten lucky. On a free response, when I make the key, I'm a little more thorough. I'm not thinking about breakfast tacos or whatever I'm thinking of, another cup of coffee. And I would know that it would be a negative. And if you don't consider the negative, you would lose a point or two. Okay. Yeah. All right. I think that's a good place to stop for today. We'll save the others. We should be able to finish maybe on Monday if we boogie, but maybe it's looking like a Tuesday finish.
So no Monday test.
No Monday test. No Monday test. We're looking at Wednesday test possibly. Okay. So kind of mark your calendars for a Wednesday exam.
That's a good day.
That's a good day?